students, welcome back to Wisdom Academy YouTube page. In the previous video, you have learnt about Ohm's law and you have seen about carbon resistor. I hope you have solved enough numericals based upon carbon resistor and Ohm's law. If so, good. If not, I request you please go and solve the questions. Only then you will get concept in questions of resistivity. Generally, we get confused in resistivity. When you solve numericals based on resistivity, you will do some mistakes. So, my suggestion is to solve n number of questions to become strong in a topic. Today, our topic of discussion is drift velocity and relaxation time. Before going into this, I want to tell you what are the charge carriers. So, if you see different types of element, if it is a conductor, if it is an insulator, or if it is insulator, anyhow, there will be no charge carriers. If it is a conductor, if it is semiconductor, if it is liquid, or if it is gas, everything will have different kinds of charge carriers. For example, in metals, electrons, we have free electrons. You would have studied about metals, it will have some excess free electron, and those free electrons are only responsible for the movement of current. If you talk about semiconductors, we have both positive particles as well as negative particles. Positive particles are called as holes and negative particles are called as electrons. They are responsible for the movement of current. We have liquids in which we have anions and cations. For example, if you have copper sulfate, then copper 2 plus ion, SO4 2 minus ion, they are responsible for the movement of current. And so in the case of liquids, we have these ions as the charge carriers. Gases also we have ions. In some case, we may even have electrons for the charge carriers. So with these things, we have understood that the charge carriers can be electrons or can be even protons. Now let us talk about drift velocity, and let me take an example of a particular conductor. So in conductor, I have told you that the electrons are the major charge carriers, and electrons are the particles which are responsible for movement of current. One thing, don't think these electrons are very less, it is a huge number. So if you remember your basic classes, you have learned that in the case of solids, the atoms are tightly packed. So it is very tightly packed lattice. So what happens, every atom is very nearby to each other. So each atom will have some free electrons. Those free electrons are getting attracted by the nearby atom. The protons are attracted. In that way, your electrons keeps on traveling here and there in the case of a conductor. So in conductor, if you ask me how many free electrons are there, so the free electrons in the case of conductor is in the order of 10 to the power 28 to 10 to the power 30 per meter cube. So in each meter cube, the number of free electrons would be in the range of 10 to the power 28 or 10 to the power 30 electrons. That is a huge number. That's when that many free electrons are there. So what happens when these free electrons are present in the conductor? Let me assume they are like this. They move here and there. It moves like this, it moves like this, it moves like this, it moves like this, and every particle, every electron moves in random direction. So when they move in random direction, the net velocity cancels out each other. I think you understand what I am trying to say. So if it is moving with velocity u1, if it is with velocity u2, if it is with u3, u4, u5 and un, each particle is having its own velocity. The net average velocity is 0. That's the reason all the electrons are not moving in a particular direction. They are moving in random direction, and the net velocity will cancel out each other. I mean to say that in this case, u1 plus u2 plus u3 plus up to un, if I divide by n, that will give me the value of average initial velocity, and average initial velocity will become equal to 0. So why did it become 0? Because I said you they are in random direction. But this is the case when your electrons are not being applied by an electric field. Now what I do, I just apply some electric field to it. So this thing, if I apply some electric field to it by putting some EMF, then what happens? These electrons are drifted in a particular direction based upon what is the electric field. Suppose this is the electric field. So this is the current direction movement. So there is some electric field setup. Suppose this is the length of the conductor. Then based upon what we have given, we know that electric field will be equal to V by L, isn't it? So based upon that, electric field is produced. Electric field, suppose it is present in this direction, then all the electrons being negative in nature will be drifted in the opposite direction like this. This is what happens when you apply some electric field to all the free electrons in a conductor. All the electrons are drifted towards one direction now. Now, when they are drifted, they are all are moving towards one direction. There is a possibility that inside we will also have protons here and there. These protons and these electrons will have some collisions. Electrons while moving, it will hit some proton, it may hit some electron also. So, when the electrons are drifted together in one direction, it is a possibility that there is some collision between electron-electron or electron-proton. That collision will reduce the speed. Suppose you are moving with a car with a very high speed and suddenly you hit by a speed breaker or something, your speed will get reduced. Again, when you are allowed to move, you start moving fastly. So, this hitting, this collision will lead to the stoppage of current. Now, I think you will be able to recollect about resistance. So, I said you resistance is a property of the material. So, like for example, resistivity of copper and resistivity of nichrome will be different. Resistivity of aluminum will be different. The reason is their nature is different, their lattice formation is different. So, if the electron is when the electrons are moving and it is the time taken for the electron to hit another particle is more, then what will happen? It will have more time to move. So, it can move a larger distance. But if it is immediately getting hit, the collision time is very less, then the resistance will be low because its speed gets reduced, right? So, I will come to the topic a little later. So, what I am talking to you now is about what happens when you put the electric field. When you put the electric field, all the electrons are drifted in one direction, and with what thing? We know that force, the force on these things will be Q into E, isn't it? We can even find what is the acceleration of these electrons. So, we know the formula of acceleration. So, acceleration is equal to, F, we know F is equal to ma. So, what will be A? A will be equal to F by m. So, acceleration A will be equal to F by m. And what is F? F is Q into E by m. What is electric field? What is Q? If you take up one particular charge, then if I am talking about electron, it is minus E. So, the acceleration is equal to minus E into E by m. This is the value of acceleration of each particle. So, if I am taking n number of particles as the example, what happens when you apply some electric field? They are drifted and their velocity will increase. Why the velocity will increase? Because there is some force acting on it. When the force is acting, suppose you are moving with some velocity and suddenly some force is given to you, it will move faster, isn't it? So, its velocity gets increased. So, suppose velocity, what will be the velocity attained? V for one particle I am telling. So, V1 will be equal to U plus AT. So, U1 plus A into T, let this be T1, okay. So, U1 plus AT1 is the velocity attained by the first particle. Like that, if second particle if I take, then that will be equal to U2 plus AT2. Same way, up to n particles, it will be Un plus ATN. So, this is how the velocity of each particle will change at the moment you are applying some electric field on it, because the moment electric field is applied on the electrons, there is some force on the electrons. So, when I club it together, what I get, you see, I get if I take average of all these things, so average velocity, it will become V1 plus V2 plus V3 up to Vn. Now, put the values of V, you will get U1 plus AT1, isn't it? Again plus, one second, if I am writing average velocity, then this will be this much divided by n, isn't it? So, when I just put the values, it will become U1 plus AT1 plus U2 plus AT2 plus like that Un plus ATN divided by n. This is the average velocity. Then if I go further one step, I can separate all the U1, U2 terms, then I will get the expression something like this: U1 plus U2 up to Un divided by n plus, if I take A common outside, it will become again T1 plus T2 plus up to Tn divided by n. This is the average velocity. Now we know that this value is 0, we found from where? So 0 plus A into this T1 plus T2 plus up to Tn by n. This term, that is the average time of all this collision, is called as relaxation time, denoted by tau. This is called as tau, and drift velocity is Vd. So I get the expression as, final expression I am getting as drift velocity is equal to A plus, or sorry, A into tau, where tau is the relaxation time. So how will you define relaxation time? It is the average time of successive collisions. So suppose one electron for taking time T1 for collision, second electron is taking time to T2, and all the electrons take the time T3, T4 up to Tn. So if you take the average of all those times, that time will be known as relaxation time, and drift velocity is A into tau. A is the acceleration of these particles. If someone is wondering why I have taken only A, why not A1, A2, when we apply an electric field, everything will have same acceleration. All the particles will have same acceleration. You can even put the value of A here, then it will get modified. It will become A is minus EE into tau by m. This is the expression of drift velocity. The drift velocity is also written as minus EE into tau by m. So we have understood that drift velocity is the average velocity gained by the free electrons in the direction opposite direction of electric field, right? And what is relaxation time? It is the average time between two successive collisions of electron. So now let us try to derive a relationship between drift velocity and current. So for that, what I will do, I will take one conductor, and in this conductor there are a lot of free electrons present, and what I am going to do, I am going to connect this conductor with a source of potential difference like this. So when I connect it, the current starts flowing in this direction, and there is an electric field set up in this direction, right? So when the electric field is set up in this direction, we know that drift velocity, the free electrons will move in direction opposite direction of the electric field. So our electrons will be drifted in this direction with drift velocity Vd, right? If the area of cross section of the conductor is A and length of the conductor is L, then its volume will be A into L, isn't it? Volume of the conductor will be equal to A into L. So why I am finding this? Because in your general life, practical life, it is not like we will have a specific dimension of length and area. It can be anything. So what we will find? We will find number of electrons per unit volume. So number of electrons per unit volume, number of electrons per unit volume will be equal to what? Will be equal to E into A into L, isn't it? And then total charge will be equal to, total charge is Q, and what is Q? Q is NE, so N into E into A into L. This is the total charge of these electrons. Now we will try to find what is the current. So what is current formula? We know I is equal to Q by T. So Q we have found, NEL. Let us try to find what is time. So time taken for the electrons to move from this end to this end, the time will be equal to what? We know that speed is equal to distance by time. So time will be equal to the distance by the speed. So it will be the distance travelled by the velocity of the electrons. So what is the distance travelled? L. And what is the velocity? Drift velocity, isn't it? So I will put these two expressions. I will put the expression of time, I will put the expression of total charge in this equation. I will get the value of current. So Q is equal to NEAL, time is equal to L by Vd, L gets cancelled. So I get I is equal to NEAVT. Very important relationship which will be used in many numericals, the relationship between current and drift velocity, and that current is equal to NEAVD, where N, what is N? Tell me what is N? N is the total number of electrons, E is the charge on the electron, A is the area of cross section, and Vd is the drift velocity. So this is the relationship between current and drift velocity. We can even find a relationship between current density and drift velocity. So what is current density? We know that current density J, current density, that is J, is equal to I by A. So J will be equal to I by A will become NEVD, isn't it? So we can write in vector form. So vector form I will write J is equal to NE into Vd. This is the vector representation of relationship between the current density and drift velocity. So this relationship gives me the relationship between current and drift velocity. This gives me between current density and drift velocity. So we have talked about resistance, and we know that by Ohm's law V by I is equal to R. So let us try to derive the Ohm's law by this method, by the concept of drift velocity, relaxation time and current. We will try to derive the Ohm's law. So we know that now we have come to know I is equal to NEA Vd. So we know the formula of Vd. In the before some time we have derived what is the formula of Vd, and Vd was equal to how much we got? E tau by m. I am talking about the magnitude of drift velocity. Minus sign was there, it was the with direction. So I am telling drift velocity's magnitude is equal to E tau by m. So when I put it here, so from this expression I am getting I is equal to NEA. Instead of Vd I am using E tau by m. Okay. Now electric field E is equal to V by L. So I can write this as NEA, actually E square will come, and instead of E I will write V, tau is there, by m into L, right. So if now this by this expression I can relate V and I. So I will write V by I, that will become equal to mL by N E square A and tau. Now if you see m, what is m? M is the mass of the electron, L is the length of the conductor, N is the number of electrons, E is the charge on the electron, A is the area of cross section, tau is the relaxation time. So cannot you see that this whole thing, if it is a constant, then V by I is equal to this constant R. So now we have found literally what is the value of R, and value of R is this thing, mL by N E square A tau. So we have understood that resistance is equal to mL by NE square A tau. Now if you see here, mass is a constant, N is a constant, E square is a constant, L, A and tau. So we understood that resistance depends upon the length of the conductor, resistance depends upon the area of cross section, and resistance depends upon the tau, that is relaxation time. So this already we have seen when we talked about the cause factors affecting the resistance. We told factor affecting resistance are length, area of cross section, and tau means nature of the material. See, I will talk about this relaxation time in few minutes. So now if I want to find resistivity, we know that R is equal to rho L by A. So what will be rho? Rho will become equal to R into A by L. So when you put it here, R is mL by NE square A tau into A by L. These two gets cancelled, and you get resistivity is equal to m by NE square tau. So cannot you see that resistivity is not depending upon the length and the area of cross section. It depends only upon these quantities, and everything is constant, only tau remains. But tau is responsible for, tau is caused by nature of material. What I'm meaning by that I will tell you now. So if you see different elements, it will have a different atomic structure. The lattice structure will be different. So what happens? Tau means it is the average time between successive collision of the free electrons. So what happens if the lattice formation is in such a way that the time between two collisions is more. So if time is more, resistivity will be less, and resistivity will be less, it will be called as a conductor. Are you understanding me? So resistivity depends upon the relaxation time. If relaxation time is more, then resistivity will be less. If time is less, that means they are very close to each other, and very immediately it hits the free electrons hit some positive ion, it loses energy, so resistance will be increased. So resistance is also caused by the relaxation time. I hope you are understanding what I am trying to say. So that's why we say when we go at very lower temperatures, we can convert conductors into superconductors. Why we say that? Because at very lower temperatures, the activity of these electrons will come down. When it starts moving less, then the less movement of electron will reduce the relaxation time. I mean the relaxation time becomes too much long, so not reduce it, it will become too much long, it will not hit itself. So if it is taking too much time to hit this, the resistivity is decreasing. If resistivity is decreasing, obviously your conductivity is increasing. So this is how we relate conductivity or resistance or resistivity with relaxation time. So in today's class, what you have learned about drift velocity, relaxation time, and the concept of resistance and resistivity in terms of this Vd and I. So I hope it was understandable. For any doubts, you can always comment in the comment section. Please like the video, subscribe the channel and share with your friends. Thank you.